Hi guys, welcome back. So today we will continue working on our project. Does this work? Yeah, it's relatively work. I'm trying to upload it on YouTube, but yeah, let's check the memory usage. It's used around. It uses a lot of memory for some reason. You have a YouTube Studio. Ah, it used like more than 24 gigabyte. Yeah. Use a lot of memory. Oh well. Okay. Finish work. Let's go to our project folder. CD document. Go to CD window project. Don't worry. There's a lot of people here. Okay. Go to open. I think you can use this command, but you have to set it up on Visual Studio to be able to use it effectively. So let's use open because it's kind of default. Screen cap. Let's see. Um, yeah. In the last one, I think we managed to open the file, and we kind of demuse it, like we separate the video and the audio, and then we write it into a file. But that was not a good idea because every single because it will decompress the file and save every single frame, and when one frame should be a few megabyte, so my 2 hours video is like 800 gigabyte with more than 200,000 frames, which is not good. Yeah, we definitely don't want to write in it. Yep, we don't want to write in it. Oops. Oh well. So I think we can modify it a little bit. Yeah, let's modify a little bit. Yeah, let's modify it. Let's modify it. Yeah, let's modify that. Is this the main function? No. Hey, where does this come from? Where does this come from? This should be come from the if. Oh, open codec contest. So if it's success, that we successfully demusing. So yeah, let's go to the. Hey, it's almost done. To the FFmpeg example. Let's go to here. Go to demuse and decode. I think we can demuse it separately, but no. Okay. Yeah, we don't want to write it into a file, which is not a good idea for some video that's like 2 hours long. Yeah, we demuse the video successfully. We flush the decoder. Oh wait, I think I did something not right. Oh, my bad. Apparently I have to go outside of this, but I cram. I think I cram all of this section into this one if. Into this no. I think I cram all of these things down here into this if, which is not good. Yeah. So, oh, my bad. That was not a good idea. That it's not a good idea. Okay, let's move it outside like that. Buffer size. Let's half of the screen. Also, this one go to half like this. Yeah. Video buffer size. Okay. Oh wow, gotta move it in here. Just now, I suppose supposed to move it like this. Gonna take a while, but let's fast forward that. If codec for audio success, you're going to try to dump all the information in there. Yeah, sorry, it's a lot of noise in here, but yeah. App go to the packet, open the packet, red, go to and video, print app, audio stream, yeah, and it's while loop, and read the frame from the packet. Why do we need a packet? Not sure. While AV packet, oh, my bad. Yeah, let's not writing it in plus the decoder. This one, this one, this one, this one, this one, this one, this one. Oh, yes, the music success. The music success. So we're gonna check. Yeah, I think we can stop here. We only need to demuse the video. So let's go back to the YouTube. Run out battery. Let's see. Video that I like. This one, FFmpeg. Extract video frame and save them. How many frames do we want to write in there? Yeah, how many frames we do write in there? Decode. Wait, unpadded line size. How did he write that?
Hello, this is Steph. Today we're going to see the first tutorial of
The first tutorial. I think it's kind of loud, so let's reduce it a little bit. Okay. Not sure how to work.
series that we compile the other time, so the other...
Wait, just 1 second. Let me go to the source code. His source code. To do his, go to his repository. Tutorial 1. Yeah. He saved the frame as a ppm file. Wait, what is ppm file? I forgot again. What is ppm file? Is a simple uncompressed text-based color image format for programming, image processing, and Linux. Yeah, I think you want to save the frame in the ppm portable pixel map. So how did he try to save it? Oh, fwrite the frame data, dframe line size. Close the file. Oh, we try to save the frame and raw to video file. iframe, how many frame, right? Oh, how many frame do he want to use? He used like frame to process 5. Okay. he tried to say the frame. Oh, he want to use like only 5 frame, right? So yeah, audio frame, output video frame, frame count. Oh, how do we limit the frame that we want to decode? Yeah, open codec. We kinda want to dump it, the packet. Oh, read the frame. Ah, right here. I think we can make one more argument to limit the amount of frame that we want to decode. Okay, understandable. Let's use static int match frame output equal 5. Yeah, let's use it somewhere around this one. And then yeah, we don't want to make like more than 200,000 frames. That is not a good idea. He used the ppm file, right? I think it's kind of well, image to copy. Oh, I less than. Wait, where's the while loop? Do we need int I? Yeah, let's make an integer here. I equals 0 and I less than maximum frame output. So every time he finish, he going to add 1 frame, or I think in here let's use I++. And also I++. Yeah, good to be so. Oh wait, I think I forgot how it works. If one if work, will the other be skipped? In programming. Okay, yeah. I++. Wait. Packet unwrap. Okay, at the end, go to I++. Or ++I. Yeah, let's try to see it. ls cd audio frame, video frame. Okay, everything good. Let's see, where's the thing? No, not this one. Okay, yeah. Oh wait. Yeah, and test 2 basic window init, audio and video, audio app, video app. Wait, is it video come first? Wait, so we want to, is it the video come first? Yeah, video come first, video come first, video app, audio app, maybe it doesn't matter. Oh, 1 2 3 4, yes, yay, 5 frames. Okay, add CD, video frame, open video app. Or what? No, I think that's not how we read it. You have to wait. What is this write into? Fwrite data. How did he write in here? Pframe data. Huh? ppm. Oh, he write a ppm file. Can we modify that to make into a ppm file? Oh, okay. Can we open that one? Document, window, project, video frame. Oh wow. How many? Yeah, only 5 frames here, right? Oh, he put in the video frame. Wait, why is audio frame does not work? Does it work for audio frame CD? Oh wait, I think there's something wrong with this loop because it only works for the audio. In other words, let's give it to the stream decode packet. Wait, how will we make into the ppm file? Yeah, I think we can craft a command to save it into ppm file. Can we grab it? Yeah, ppm. Oh yeah, I think for the video frame should be dot ppm. Cool. Okay. ls rm video app cd audio video frame rm audio dot app audio app cd, go back and then compile it. Okay, test 2 basic video app audio app. Cool. And cd. Oh wait, my bad. Window project and go to video frame. Yeah, we look at this. Wait, I I think in here he write in the a separate file, but in our code we write in the uh, we write in the same one. Oh, we have to close it. Okay, you have to close it. Right. Okay, right to the file. Close. Wait. Oh, we did not close the file. I see. I see what is happening. Oh. I think we can make. I think we can modify this one a little bit. Could not open the destination file. Open codec. I think we can group this one. How are we going to group this one? Codec. Okay. In this code right here, he can make a multiple ppm file as one file for the frame, but in here they kind of cram everything into one single file. So I think we want to separate it into multiple files. I don't know how can we do it. It's kind of hard to do, but it's not impossible. Oh, okay. I think we can just make a new function. Yeah, let's make a new function. Static void. Yeah, let's make a new function. Okay, static. Let's refactor it. Save frame. So I think we don't want to. We kind of want to use this one. Yeah, we only need an AV frame. Yeah. Okay, let's just use this one. Let's AV frame. AV frame. AV frame. Go to the frame. I want to copy all of this. I will take this. Oh wait, no. Oh no. I think I don't want to. I don't think I want to. I don't want to save every single file, every single frame as a file. It's work for a small amount of frame, but as we have more and more of it, yeah, it will be hard to do. So yeah, I think this one is good enough. This one is good. I don't really need to do anything. This one is good. Okay, cool. So yeah, we kind of want to limit the amount of frame we have. Okay. Yeah, I think this will be good. ls rm video f.ppm. Huh. Oh wait. What if we just one? Just have one. rm video f.ppm cd audio frame rm audio f. Okay, let's compile this once again. If we can use that one. Test 2 basic video app audio app. Cool. Let's see if we can use that. If just one frame. Oh, maybe doesn't recognize the format. Oh no. Wait, I think in here he used the plus I multiply line size, but he used this copy spec non-aligned data. Oh, user format. Wow. Use one. And here he used the the data 0 image copy to oh wait what does this really do? Image to copy. Why do we need this function? Yeah, image to copy. The copy work around the limitation the conversion from unsigned in a constant inside in. Wait, what does this really do? Copy image from source data to destination data. And what? Oh, I see. Just one frame. But in here it's just 0. If we just use 1 0, but in here we increase it. Oh no. With a yeah, I don't understand. I don't understand. Video frame CD video frame IF video app IM video app.ppm. Yeah, I guess we don't need it. Okay. Wait. Let's remove this one real quick. Yeah. CD audio frame IM audio app. IM video F IM video F. Wait, run out battery. Yeah, almost. Okay. Yeah, so far so good. What will we do?
We said how AV frame with the allocation of the frame. And then we have the packet. The packet is like so a piece, let's say, of a frame that needed to be taken out of the stream in order to populate the frame itself. Now, this is the input frame. The one that we have after pframe RGB is the output frame. So we're going to take the input into the output. So we take from the video file the frame, that is pframe, and then we are going to save what we have in pframe into the pframe RGB. So we allocate it the same way we
Got a packet, yeah, frame, packet, alloc, this, the same thing.
had before. So AV frame alloc, same method. And here we have this SWS context. So this is the scale context. Usually it is done for filtering. Here what we're going to do is a simple color space conversion, because by default we have the data that come as YUV or Y, so YCBCR, and we want as output the RGB. So we pass from YCBCR, YUV, into RGB.
Oh, okay. So, while you reframe, do we make that function here? No. Oh yeah, that's the built-in function. Built-in function takes a packet from the stream. 0. Read from save frame to disk from a file. Okay.
Here we set the number of frames to process. So the numbers of frames to process here is equal to 5. If you want to change it, you can. So I want to take only the first 5 frames as it was in the original tutorial. So if you want to change this number, you are free to do it. And then we are resetting the loop to 0, because this will be used in this internal loop that while we read frames, in this case it is a while, then we are going to break after if it is when it finished.
Wait. Oh wait, and we have to convert into RGB. Really? Do I need to? Oh, allocate image. I think I think I understand.
So we have
I think I understand why he have this one. He have this big stroke right here. Conversion, because he wants to convert from the YUV format to RGB. Oh, I see. That's why I need this one. P codec. Where's the P codec? Where's P codec? Yeah, P codec, AV codec. But we have like a function here to decode packet. No, AV codec. Yeah, right here. Codec contest, open codec, init the decoder. Okay. It's complicated so far, but Let's try to figure it out later.
It is a while, then we are going to break after if it is when it finished. So we have this AV read frame with this format context and packet. So you need these two parameters to take out the frame. And here we have the limit, the break limit. So if we are before the frames to process, we can go on. Otherwise, we stop. So here we take out a packet out of the video file, and we say, is this about the stream we are looking at? So the stream index is belonging to the video we are looking at. If it is, we go on. Otherwise, we don't do anything. So we're going to decode the video frame with this method. In this case, this is the new thing that is in this FMPEG AV codec send packet, and then later there is the receive frame. So there is this passing.
Oh, so like that. So I guess we don't need this function decode packet. Oh wait, here, send packet. Receive frame. Oh wow. So he really simplified it a lot for us to understanding. Oh, thank you.
Of a packet from one way, the input to the this passing from like server and client. So we have the send and receive from the input and the output.
AV error EUF.
Then here, okay, these are all error management. And so if we have the full finished frame, so here we are composing the frame until we have the full frame. So if we have a full frame, that is because the frame finished variable that is right here is not with a value that is below 0, or it is not of this kind, AV error or end of file, we are going on making up the frame. Once the frame is made up, once the frame is fully composed, we are going to allocate the output frame. So we're going to
allocate the output frame. I think we kind of did that. Do we? Did we do it? Allocate the output frame. Oh, we did it all the way here. I think one brief. No. Decode. Oh wait, we only decode before. Okay. Open pad. Oh, okay. Here we decode. I think we can allocate later, right? Decode reframe on the file.
allocate it using the data that are in. So these are the input and the size. Let's say line size is how many rows we have. So how many with the height of the video, basically. And here we have the data as output and also the size as output, as we can say. Then we have the size as width and height coming out from the codec. So this is the input, and which is the color space we want to use.
Okay.
So here we use the conversion. So this is the process of conversion between the input, that is YCBCR, YUV, into RGB, and this is the process of conversion. So here now we have the frames from the YCBCR into the RGB, and then
Okay, we use B frame. Wait, what is B frame? What did he get it? B frame. I think he allocated for that B frame. No. B frame. B frame, B frame, B frame. Wait, I think I'm lost a little bit. B packet. Where did I get B frame from? Oh. Right here. Allocate for the frame. Oh, wait, not okay, AV. No, go up a little bit. Codec. Fine stream. Oh, okay. Could allocate video frame. Yeah, I think we have it. Allocate video frame. Yeah, right here. Frame alloc. Oh, I think we can convert them using this function. Wow. Oh, so that's how we do it. That's why he was able to open this format right here. And I think in our code we only save them as it is, and it's from YUV. So, and they use other function to convert it. That's why it's not really working.
In the RGB, we take this frame in RGB, and we're going to save the frame. So we go up to the function that we had in the beginning, that we skipped before, and here we are going to open an output stream with a file name that is being decided by the this thing. So here we're going to take the name of the frame based on the counter that we have. In this case, it is the counter +1. So it is 1, 2, 3, 4, 5. No, 0, 1, 2, 3, 4. We open the file, and just in case there's an error, we're going to get out with an error. And here we put the header of the ppm file. The ppm file requires a p6. So in other sites you see p5. It depends if you have a color frame or grayscale frame. If it is a color frame, you have it with the p6 in the beginning. If you have grayscale p5, color p6. In this case we want it in color, so it is p6 with width and height and values that are up to 255.
P5. I see.
The values that we are expecting. After, we are going to write the pixel data. So as soon as we have the data inside, so here we have the data put as stripes. As you can see, so we're going with the height, and we're going to put line by line all these bytes, and in the end we close the file. As soon as all the frames are done, we are going to unreference and remove and free all the memory dedicated to all the things that we used. So we
unreference. Let's see. That's why they have it. They have it here, and also after they decode the packet. Yeah, that's why. Okay.
Open the packet and we close it. We close the context. We close the input and the output frame. We close the codec and we close the format. So this is a good manner to avoid memory leaks all around.
Yep.
And then we return to 0. So this is the basic way to work with FFmpeg. The rest will be built up upon this knowledge that we did. So I hope that in the next tutorial we don't get so much in detail with all the things that we've done in this first tutorial, but we see the differences between this piece of code and what we're going to see next. Okay, so we reached at the end of this first tutorial. The next time I'm going to see the second and so on with all the others. And we're going to see the differences between what is in this and the next. And so if you reached up to this point, thank you very much. And please like, share and subscribe and hit the notification bell to get notified about the next videos I'll be releasing. And for the moment, I greet you. And so please stay tuned for other videos regarding multimedia, but also much, much, much more. Ciao! Ciao!
Okay. Yeah, thanks. Thank you. Wait just 1 second. I will stop recording a little bit. Okay, guys, I'm back. So apparently, I just reset my window to try to free up all the memory to make it work faster. Yeah, to make it work faster. And yeah, so far so good. Nothing really significant. Yeah, no swap use, no compress. Cool. What if I open YouTube FFmpeg? Wait, FFmpeg example. I open the code and one more app, YouTube. Go to the thing that I like. This one. No. Yeah, this one.
Hello, this is Steph. Today we're going to see the first tutorial.
And hello, Step. Let's go to part 2.
Hello, this is Steph. Welcome back to my channel. And today we're going to see the tutorial number 2 about the FFmpeg tutorials. So the other time we checked out how to extract the frames out of the video and put them in an image file. So at least the first n frames of a video. And this time we're going to play the video. So we're going to open an instance of player and we're going to play the video in. So here we have Ubuntu ready. So we're going to use Visual Studio Code as the other time. And if you didn't do it, please like, share and subscribe and hit the notification bell to get notified about the next videos I'll be releasing. And now it's time to get started. Okay, here we are. So this is Visual Studio Code and here we are with the tutorial 02. So if you would like to execute the program, so it's better to see, to take a look what the program does, we can go and compile. As the other time, here we have the build target into tutorial 02 and the launch target into tutorial 02 as well. And then we're going to compile. Here, as soon as the program is finished, so here I've already compiled it because the other time it took a lifetime. So as soon as we finish, we have the program ready. We are going to run and debug and then run with the launch task that we had before. And we should see a window appearing. Okay, so it's the debug mode is a bit slow. Okay. And let's see the window opening. It's a bit slow. It should be faster on your PCs. It depends on the power that you have. And by the way, you should play the video in its entirety. In this case, it takes the video stream and it will play it from the beginning to the end. So we don't have any controls. We don't have anything. As you saw, it takes the frames out of the video and it pushes them, it shoots them into the SDL interface. Cool, so now let's see the inner workings. You will see that most of the code that we are dealing with is very similar to the code that we saw the other time. In fact, there are the first inclusions, AV codec, AV format and SWS scale. And we have new entries here. We have SDL and SDL thread. So what is SDL? SDL is a library that is mainly used for gaming, video gaming, SDL. So to display.
Oh, I think we already have SDL. Open window init. Yeah, we only make that here. Yeah, we only have that. Yeah, we only have that one. Very cool. Yeah, so far so good. Basic window.
Game and yeah, so interface visually with games, and now it's used to render the video out of this window. So here, the first part of the code is identical. Apart this, that is the initialization of SDL. So let's say the initialization of the SDL library. In this case, we want the video, the audio, and the timer. There are also other things, joysticks, input, other types of output, etc.
Yeah, I think we have a whole function for it. We add init, cool, create window renderer, set window logical presentation, good.
But in this case, we want video, audio, and timer. Even if we don't use the audio, we want the video only. Apart this, for
Wait, SDL init audio? Huh, okay, init video, so we need to add the audio. SDL init audio. Oh, so also the timer. SDL init timer. A font.
of code, 5 lines of code. The rest is identical to what we saw the other time. So we have the initialization of the format context, so where we take the file, we open the file,
Yes.
we find the first video stream, and we take the information out of the codec from the first video stream. We take the context and we take the parameters and we put in the context, codec context. We open the stream and we are going to allocate the frames. So here we have this P frame, that is the input. In this case, frame YUV is the output frame. We can go to the SDL window. In this case, we're going to create the window itself with these flags. The title will be tutorial 02. You can change the name here to see what you want. For example, the name of the file. And here you have the width and the height of the video.
Wait. Create window. Create window renderer. Window title. Window width, window height.
What you want, for example, the name of the file. And here you have the width and the height of the...
Oh, okay. I think we need to somehow figure out how to link all of this embed code with this STL3 library, which is not an easy thing to do. What other way we can use to link two C files together? Can we do it? We don't need a main function, don't we? We just need a main function in one of the things. Oh, okay. So I suppose we can turn this one into the util function, and we can use that in here. So window init will be our main driver, and the string cap will be for us to handle the video processing.
Video with also other things like SDL windows or resizable. So
window OpenGL. Oh, should we use OpenGL renderer?
can resize the window afterwards. Error if it cannot be initialized for any reason.
Oh wait, STL create window. Let me just take the argument. STL create window renderer. Create window renderer. Create window flag. In with hey. Okay. He used OpenGL, right? Yeah, I think we can use instead of resizable. Let's make it be fizz. Window OpenGL like this.
And then you have the render, so with what you're going to put in the window, and then you have the texture that is, let's say, the canvas where you're going to fill with your own frames.
Wait, texture. SDL texture.
So with what you're going to put in the window, and then you have the texture that is, let's say, the canvas where you're going to fill with your own frames.
Wait. SDL create texture. Oh, we need a texture. Ah, I see. Oh. Return the create texture node for rendering context, enumerate the value in pixel format. Texture access. The width, the texture, the height. Okay. Window pressure. Wait. STL3 example. I think because we don't really have a main function in STL3, so if we do something like this, oh yeah, we don't want a main function. I think I will remove the main function in here, and turn all of this step into a function, so that we can use it in this SCL3 file. Yeah, in the app iterate in here. Okay. So my goal is like this: GCC. Wait. Let's see. OS RM test GCC window init.c o test. Wait, let's link the library. pkg config c flag lib SDL3 init timer. Oh, SDL init timer. Wait. My bad. SDL init timer. SDL init. SDL3. Oh, wait. I think I forgot about that. Include SDL3. SDL init. Init.h. Yep. So init video resizable. I don't. Yeah, we don't want this one. We don't want this one. Init flag. Yeah. So we link that library. Should probably work. Initialize SDL library. init timer. Oh, do we have init timer? STL init timer. No, we don't have it.
Also a rectangle and an event to manage the events.
Oh, we only have that. Manage the event, add event right here. We can add it later. Oh no. Where did he get that from? SDL.8 thread. Oh, wait. SDL init. Wait, where's the init one? Yeah, timer. I think we don't need init timer. Yeah, just audio is good. Audio is good. Wait, how many? 25. Yeah, apparently we use a lot of thing. Yep, the YouTube really take a lot of memory. Okay, we don't have the timer, so that's okay. Test. Yeah, so my plan is we have a field right here with a rectangle, and I can type in the video that I want to play, and it's going to my directory inside my computer, grab that video and display it here. Yeah, that's what I want to do, but that's gonna take a while to do. So I will try to figure out how to do it. I need to organize the idea in my head to link these two together, make a button that work in SDL3 app event, and then when I click it, it's going to use all the function in here. Yeah, I think we don't need a main function. Yeah, we don't need a main function. The reason is I think he used it because he wants to be beginner friendly. So he kind of simplify a lot of things.
We have inside, in this case we don't use it full power, but this is for the management of the events as soon as they are going in the window. Here we have an SWS context. If you remember from the other time, this thing would be we used it to convert from one color space to another. Here we're going to let's say resize mostly. So if you
one color space to another. Yeah, we will definitely use just this one. Yeah.
Need to resize the window, for example, you need to have this resizing to be done afterwards. Here we have the reading of the frames as it is. It is identical to what we saw the other time, so we are not going to take that. Here, what we have here is to render, to get the input frames into the output frames that they're going to be shot into the SDL window. Here we have the rectangle that is the SDL window, and we update the texture in this loop that is until we have frames. So here it says read until we have this thing. So this can be removed, I guess, because this was really dealing with something that I worked with before. And here, okay, we have this let's say while until the video finishes, until we have frames, we take them and put them in the video. So here we have this, okay, with this update texture. So it's going to update the canvas where we're going to see the data in with this data. And then we are going to update and clear as it should be. And then the loop repeats. So we have all the frames out of the video. Then after the end, we have the cleaning of everything. So we remove the reference for what regards the packets, and we remove the references, and we also flush, let's say, the events that are coming into SDL. If we have the quit, so the user requested a quit for any reason, we're going to quit. Otherwise, we're going to free everything, and the program ends. So conceptually is very similar to what we saw the other time. There's only the introduction of SDL. So we got to see well how to work with the SDL itself. So in the beginning, we have where is it? I'm lost. Okay, here we have the initialization of all SDL. Then we have after that, after we initialized everything, the initialization of the window that we have inside SDL. We have a renderer to render the canvas, the canvas itself, that is the texture inside with this rectangle. And then we have this conversion, just in case you need also some resizing. We have this SWS context that takes care of everything. And we are converting from the input frames into the output frames. And then we are going to update render and do whatever it's required. Okay, cool. You see that it's very elementary. We don't take care of something, you might guess what, but this is a good start. So at least we have our first player. So we reached the first player ever in in our steps. Good. Okay, so we took a look at all the SDL without taking care of frame rate and all these.
Yeah, I think I understand what he say. Yeah, so far that's what we do today. We just fix a few errors, addressing a few things, and try to plan for the next one. Yeah, I think I will remove the main function in here. Turn all of these steps into a separate function, and then we can use that in here. Yeah, very cool indeed. And we're gonna make a new button in here with a square. Yeah, so far so good. So yeah, I think that's all for today. Try to save it and then say it one more time. Set it up. Wait, how many memory did we use? Oh, okay. My laptop fan is working really hard. Did this network CPU? too bad. So, oh, I guess that's it. Okay. Yeah, I guess that's it for today. Just try to plan ahead a little bit. No, wait, before I quit, that's okay, I think I have some idea. Yeah, here, you should want this one. Let's see. There's final scene. This one. It's like how many? Salary final scene. I think I really like this. I really like this one. Final, not this thing. This one right here. Yeah, this one right here.
People waste 1,400 hours a year.
No. Bye bye.
Leave me alone.
I cannot leave alone a soul in pain.
Do you know who I am?
That makes no difference. All men are equal in God's eyes.
Oh, okay.
Are they?
Offer me your confession. I can offer you God's forgiveness.
How well are you trained in music?
I know a little. I studied it in my youth.
Where?
Here in Vienna.
Ah, then you must know this.
I can't say that I do. What is it?
It was a very popular tune in its day. I wrote it. Here. How about this? This one brought down the house when we played it first. Well,
I regret it is not too familiar.
can you recall no melody of mine? I was the most famous composer in Europe. I wrote 40 operas alone. Here. What about this one?
Yes, I know that. Oh, that's charming. I'm sorry, I didn't know you wrote that.
I didn't. That was Mozart. Wolfgang. Amadeus Mozart.
The man you accuse yourself of killing.
You've heard that?
Is it true? For God's sake, my son. If you have something to confess, do it now. Give yourself some peace.
You was my idol.
What about this one?
Done.
yeah, I guess that's pretty much it for today. Thanks for watching. Yeah. Bye, y'all.